Hey everyone, Matt Brunig here. I've got quite the treat for you today. I'm going to show you how to produce the employment situation report, more commonly known as the jobs report, using the Bash shell scripting language. So no Python today. If you are unfamiliar, Bash is a scripting language used on Unix operating systems. I tend to associate it with Linux, but I suppose probably Mac OS, which is what I'm using right now, is more prevalent. Well, I don't know if it is more prevalent than, I guess it's not technically more prevalent than Linux, but in terms of like end consumers and stuff like that, you're going to have more people using Mac OS X as a Unix operating system. And the reason I'm going to use Bash today is mostly because I think it's funny to do this with Bash. Occasionally, I will tell people that I can and I have done this analysis with Bash, people who work in this area, and they all kind of look at me funny and they maybe don't believe it, or they think it's really crazy. Because it's the Bash scripting language is most certainly not designed for this purpose, but it can be used for this purpose. The other reason is the first microdata analysis I did with Bash. And the reason is because at the time I was very, very prolific with Bash. I used to write a lot of scripts for Linux distributions, like system scripts. In fact, if you use Arch Linux, you can see my handiwork is still being shipped in the core distribution today. I wrote a script there called rank mirrors that is used by the package manager to rank the speed of different mirrors, and it's still shipped to the, I wrote it when I was a teenager, probably 14 some odd years ago, and it's still in there today. Very proud of that. But I was very, very good at Bash at the time, and I like to use it for uncommon purposes. In fact, for that script, rank mirrors, it used to be written in Python. There was a prior script that was written in Python, and I went to the Arch Linux guys and was like, I can actually write this in Bash, and if we write this in Bash, we can actually get rid of Python in the core distribution. And they were very impressed by this, and eventually it got put in. So I like Bash. I haven't used it in a long time, so I'm very, very rusty, but it's fun. Hopefully it'll be a little bit offbeat. And the point of this is not really to teach you how to use Bash. It's to teach you to understand this particular bit of data, which I haven't covered before, but which you must be familiar with if you follow sort of economic news at all, because this report comes out the first Friday of every month, and everyone always has a take on it. The unemployment rate is up. The unemployment rate is down. The Washington Post, the Wall Street Journal, the New York Times, the Financial Times, every publication, Bloomberg, they all have people who are just raring to go. I think it releases at 8:30 in the morning, and they all have their pieces lined up, and every sort of person who is anywhere associated with this in the like blogosphere or Twitter sphere or reporter sphere, they got their charts, they got their tables. It's tweets and tweets and tweets. People love the jobs report. I don't really like it that much. I don't really talk about it that much, but it's definitely looms large in the economic discourse. But I don't want to say I don't like it. I don't know. It's not as interesting to me as it apparently is to other people to get these numbers. Anyways, for our exercise today, what I want to do is recreate these numbers. You see the numbers I'm highlighting here in this table, right? The reason I'm going to do January 2023 is because they released the microdata at a 1 month lag. So this is the latest data that regular people have access to. And we're going to do not seasonally adjusted because that's the numbers come out not seasonally adjusted. To seasonally adjust it, you have to run it through this other program. I think it's called like X12 ARMA or something like that. Not really what I'm into at the moment. So we're just going to try to recreate these numbers here, show you how to do it in Bash, and, really just kind of walk you through the basic mechanics of it, because once you understand the basic mechanics of it, you can do it in any programming language. So maybe that's also another point here. Python, R, Stata, SPSS, SA, it doesn't really matter. You could do most of this shit in Bash if you wanted to, Not the high level shit, but like descriptive stats like this, you could do it in Perl. You could Do it in JavaScript. You could do it pretty much in anything. All right, so what do we need for this? So we're going to go to the basic monthly CPS website here on census.gov, and we're going to get the January file. Notice they have 3 versions of it: the CSV file, which is the comma separated value file, and then they have these 2 fixed width files. And the fixed width file, you know, I think I've discussed this in other videos, but the way it works is each line on the file is a row, is like a person that's in the survey. The same with the CSV. Each row is a person. But in the CSV, the columns are delimited with commas. So each comma indicates, oh, we're starting a new variable with a new value, right? Whereas with the fixed width file, there's no commas separating any of the values. So to determine what number corresponds to what variable, you have to go to specific character numbers in each line and like slice at those character numbers, and then you isolate it that way. You'll see what I mean. So what I'm going to do here is I'm actually going to use Bash to download the file. I haven't done that with any of the Python stuff, though you can obviously do it with Python. But we'll do that just again to mix it up. So I'm going to copy this link here, and I'm going to go into my script here. URL equals. Bash is a kind of an interesting language. It's got a lot of idiosyncratic like syntax that you're not going to see. I mean, I guess you will see some of this in other things like Perl and whatever, but it's, you know, it's unusual. So notice like there's no white space here. It's not URL equals like this, because if you do this, you're going to get an error. It's URL equals that. But notice, well, you'll see later, when I'm assigning the variable, I don't put a $sign in front of it. So the $sign is called a sigil, and some other languages use this as well. When you're assigning the variable, there's no sigil in front of it, right? But when you call the variable later, you have to put the sigil in front of it. So it's a little strange. Anyways, we're going to try to download this URL. And when we download the URL, we're going to get this file. And then you notice this file has a .gz on the end of it. That means that it's gzipped. Gzipped is just a compression algorithm. And we're going to uncompress it to get the raw text. So after it's downloaded, we'll have a new file, which is called jan23pub.dat.gz. Okay. And so what we're going to do here is we're going to, first thing we want to do is we want to check to see if the file exists, right? So the way this works is this F here means the file exists, right? So we're just checking true or false. Does the file exist? And if you just had the F file, then whenever if the file existed, it would give you a true, and then this would trigger as true, and then you would do the stuff that's in the little if statement, right, in the little conditional thing. But we only want to trigger this if it's not true. We only want to trigger if the file does not exist, because if the file does not exist, we want to download it. So we put this little exclamation point here to just kind of invert it. So basically it says if the file does not exist, we're actually going to take the GZ off this, because once we unzip it, the GZ is going to go away. If the file does not exist, then let's go ahead and download it. So we're going to use this program called curl to download it. And then we'll output it to file .gz. Yeah, okay. And then we will gunzip it to file .gz. All right, and then fee for finish. So this is how you close like a statement in Bash. An if statement is you just type if backwards, which is kind of funny. You think about it like parentheses, I guess. I don't know of any other language that does that, but maybe there is one. So like in Python, the way you would close the if statement is Python is white space sensitive, so you would just unindent, right? So if you just unindent, then it knows, oh, we're done with the if. The indentations in the Bash don't matter at all. You don't need to indent like I'm doing right here. It's just, for visual purposes, we're used to reading code this way, so I indent. But you don't need to indent. You could put all this on one line. Like you could do like this, and then you can separate it with a, and that's true obviously of other programs, but of other languages. But the fee is a funny little finisher there. Okay, so whoops. So if we look here, I don't have the file in my little folder here. But if I run the script, hopefully it'll download it. Yep, there it is. Woo! All right. So now next time I run the script, it'll see that the file exists and it won't download it. I'm putting this in here mostly for fun, but one interesting thing, and I guess I'll just put this in a paste bin and put it in the description of this video, is you can give this file to someone else, just like this script, and they could run it and it'll fetch the data and then do the calculations and you're good to go. I think maybe in like classes that if you do like a data class with the professors in college and stuff, I never did anything like that. I think they have you do this sometimes because they want you to they just want to be able to get the script and run it and it all goes. And I could see it's very neat to do it that way, but I don't typically do that. Okay. All right, so once we get the thing and it's open, or once we get the file on our drive, this is what we have. I've shown this before, but you notice each line is just a string, is just numbers, right? And you can see the little cursor moving up and down. This is line 1, and this is line 2, or I guess we'd say this is line 0, and this is line 1. The reason why it looks like there's a lot of lines is just because the line is so long that it's breaking up into different lines visually. But in the file, it's all one line. So you just get line, 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 line. And so what we're going to need to do is figure out where in this mess of numbers is the variable that we're trying to capture. And then use that variable, capture it for all the lines, and use it to do our calculations. Okay. So the first thing we're going to do here, I think this might be novel. I don't know, because if you go, I went to check to see how this how people tell you to do this, but if you look on Google and stuff and you ask people like, how do I read a file line by line in Bash? They always tell you to do this while loop. So the loop will say like while read, and then the file will come at the end, and then they'll do it. It's like this really complicated thing. And that's not how I do it. And I think my way is way better. So what we're going to do is, instead of using a while loop to read the file line by line, I'm just going to create a bash array where every item in the array is just a line in the file. So that's the same thing I do with the Python stuff. And to me, it's a lot cleaner. So this is a funny, I won't say funny, but an oddball thing here. So we have this special variable here called IFS, which stands for internal field separator. But what it basically does is it tells Bash, this is the delimiter that I want you to use in order to distinguish between like different parts of, in this case, the file, or really the string, right? So if you think of the file as being just one giant string, right? All these numbers that we just went into here is just one giant string. Then what you're telling it to do is you're saying, look, I want you to cut the string using at each new line. So this right here is a new line character. So we're saying at each new line, I want you to cut the string. So it's sort of like in the Python when you do dot split, and then you do a comma to like split it by comma. Here you're splitting it by new line. And you can set the IFS to anything. This is actually one of the things I used a lot back in the day that I thought maybe was slightly novel and allowed me to do a lot of creative things, was to use the IFS to help chop up strings. Because if you don't use the IFS to chop up strings like I'm going to do, you end up using external text parsing programs like grep and awk and sed, and those just just take a lot of resources, you know. And I was back in the day, I was really interested in like making Bash as efficient as possible. And you can do a lot of things internally in Bash without calling external resources. Anyways, so what we're going to do here is we're going to say data equals, okay, and then these little parentheses indicates an array, right? So you could like item 1, item 2, item 3, and this would be data 0, data 1, data 2, right? But we want to use the file for it. Now, one way to use the file for it would just be to use the cat, which is concatenate, and you would say cat, right? But that kind of breaks the fun here because I don't want to use external things. Up here, I use external things to download the file. There's no way around that. But I can do all the parsing of this stuff inside Bash, not just use Bash to call external programs. If I want to use Bash to call external programs, I could just use Bash to call Python. That's not what we're doing here. So one thing you can do here is you can actually set it up like this. Right? And this reads the file into, I think it's called standard input. And then for one reason or another, I'm starting to get vague on how this all works logically, but when it comes into the standard input and gets read in this way, it'll pop in here as like just a list. Like remember at item 1, item 2, item 3, that's how it'll show up. And then because we have the internal field separator set as new line, it's going to cut each thing at the new line, and so you'll wind up with this array where each item in the array is just a line in the file. And so one way we can check this is we can ask, we can use this like parameter expansion stuff to have Bash tell us how many lines are in this array, or excuse me, how many items are in this array, right? So this is a little thing you can do. So how many items are in the array, and we can check to see if everything's going as planned. Let's see. All right, there we go. So it says 125,982 items are now in this array, in the data array, right? And that should be equivalent to the number of lines in the file. So I'm going to use this other program. This is the word count program, WC. And then if you use the L flag, it'll actually count the lines, not the words. And if we do that, look at that. So I kind of, with Bash, just wrote a version of the word count line program. You could do it in Bash. Obviously, you see the word count line program was faster. It's, I believe, written in C. So, but, you know, fun. We're having fun here. Okay. So now that we have each line in the file in this array, we can just loop through the array. Again, if you've watched the Python stuff, you'll be very familiar. You'll be very familiar with this. So for line in data, I think I need, sometimes quotation marks matter, sometimes they don't. Okay. Okay, so now what we want to do is we want to isolate a couple of variables. So let's go into the data dictionary. So the big variable for the jobs report is called PIMLR, which is the Person Monthly Labor Force Recode, PIMLR. And as you can see, there's 7 possible answers to PIMLR. There's actually 8 because the 8th answer is -1, right? So if your PIMLR variable for a particular person is 1, then they were employed but at work. If it's 2, then they were employed but absent. If it's 3, then they're unemployed and on layoff. If it's 4, and then unemployed looking, etc., etc. But you also can get -1. And -1 means that the person is not in the universe, meaning that they are not someone for whom this question is asked. And here they explain the universe. The universe is anyone who has PRP, person type number 2. And so we can actually go find that variable and see what that amounts to. Here it is. So person type number 2 is adult civilian household members. So I think it's people 15 and above, I believe. Not an adult, but that's how it is. 15 and above, and they have to be non-institutionalized, meaning we're not talking about prisons or anything like that, and they can't be in the military, so that's civilian. So that is the universe. If you are a kid, you're in an institution, you're in the military, you're not going to get counted. You're going to be not in universe. And if you're not in universe, then you're going to get a -1 by your name. Okay? All right, so what do we do with this? So over here we have the characters in the line where this information is going to be present. So in each line, remember, let's go back to the file. In each line, we got all these numbers. So if we go to characters 180 to 181 in this line, wherever that is, you're going to find that those characters will either say 1, 2, 3, 4, 5, 6, 7, or -1. And that will tell us what the Pimler is for that particular person. So to isolate that in Bash, you use something called substring expansion. And so what we're going to do is we're going to do line, and then you start with the offset, and then you say how many characters after the offset. So basically this says go to this line variable, and remember, as we're going through the loop, the line variable just goes each line one by one. Go through the line variable and then move 179 characters down the line. And after you've moved 179 characters down the line, capture the next 2 characters. So if we moved 179 characters down the line, and then we capture the next 2 characters, we're going to get characters 180 and 181. So let's just go ahead and check that real quick, because we want all these values to either be, -1 through 7. And if we're getting other kind of weird values, then we know that we're off. So I'm going to go ahead and just run it. Oops. So I didn't close the loop. So for for loops, you close the loop with done. Now I always thought this was funny because with the if conditional statement, you close it with phi, which is the opposite of if. So why not, if we're just doing this, why not just close the for loop with ROF? Right? And close the while loop with the opposite. I don't know. That just seems like a fun way to do it, but no, we're going to do done. Okay. So let's see what kind of values we get. It's going to just shoot them like crazy, and I'm going to have to exit the program. But let's see what we get here. All right. So we get -1, 7, 6, 5. What else we got here? 5, 6, -1. All right, it's all between -1 and 7. So that's a good indicator that we got what we want to get. Okay. So next thing we want to do is we need to use weights. You always use weights. Now, there's a special weight here in this file, the composited final weight, and they tell you just right here, it's used to create the BLS's published labor force statistics. It's used to create this. So let's use that one. All right. Equals line. And then what are we trying to do here? We're doing 845, right? And then we do the next 10 after 845, right? I think that's right. I got it written here just to make sure. Yeah, okay. All righty. So the first thing we want to do, let's match our first number here. So the first number we should match is this one, the civilian non-institutional population. Now remember, as I mentioned before, Pimler's universe is anybody who is an adult civilian non-institutionalized person. And if you're not in the universe, then you're going to get a -1 for Pimler. So what we can do is we can just say, look, if Pimler is not equal to -1, then, and we should create a little counter here for population. Whoops. Remember with bash, it's not spaces. If Pimler is not equal to -1, then let's go ahead and just add up the weights, right? So we're just adding up the weights. So population is equal to population plus the weight of this line, right? So that's what this means. Now, here's an interesting feature of bash. This is, again, one of those ones that people don't use that often, but does exist, and it's a little bit unusual. It's called arithmetic expansion. So you notice up here when we did the if conditional, we used the little brackets. And that, when you use the brackets, you have access to things like this, which allows you to check if file exists. If there's a lot of things you can do with the brackets. If you want to do anything involving numbers, you almost always need to put it in these two parentheses. So here, to get a comparison, we put it in these parentheses. And so this is going to either put out a true or a false. And then that'll allow you to use the conditional statement. And this will allow you to do some math in bash. And it's weird though, because notice that when we need to call other variables in other parts of the program, we always have to start it with the little $, which is called the sigil. So you notice there's a lot of sigils. There's a sigil here. There's a sigil here. So anytime you're calling a variable that already exists, you use the sigil, except when you're using the arithmetic expansion. In that case, you're not using the sigil. So we don't do this. And we don't do this. That won't work. But notice up here, you do that. You might start to understand why people think it's a little bit nuts to do this. But, okay, so there we go. All right, so let's see what we've got. Now, before we go a little bit further, let me mention something here. Okay, so the composite final weight, notice it says it has 4 implied decimal places. That means that although you're going to get an integer with no decimal places, the last 4 numbers, you're supposed to assume there's like a little decimal right before them. And this is actually useful in this case because bash only does integer math. It does not do floating point math. It will round things. If you give it floating point numbers or what, it's going to round. And now, but if you can still kind of do floating point math as long as you're willing to keep in your mind that you have implied decimals instead of actual decimals. You can also do floating point math in bash if you use a program called BC, but now you're calling an external program to do your math, and that's not what we're about here. We want to keep it pure bash. All right. So what I'm going to do here is at the end of this, I'm going to, because of the 4 implied decimal places, I'm going to divide it by 10,000, right? But also notice that here, the numbers are in thousands, right? So this 265,962 is actually 265 million, but it's in thousands. So I'm gonna account for all of that here. So what we're gonna do is and we're doing the arithmetic expansion again here. We're going to say divide population by, we got the 4 implied decimal places, right? 1, 2, 3, 4. And then we got the 3 zeros because we're doing the thousands here, right? Okay. 1, 2, 3. All right. And now we're going to print the population. Let's see what we get. Do 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 do. Oh no. No, it's not print population. That's Python. What am I doing? I want to echo the population, right? Yeah, so if you print statements in bash are done through echo, though I think you can also use something called printf if you want to format the statement. I've used that before. That was a long time ago. But echo is the typical one. All right, great. You see this number here? 265961. Let's go to our number here. 265962. I'm off by 1. The reason we're off by 1, and I've mentioned this before in other videos, is the public data that they put out here is different from the data that they use internally in the census. They make small little edits to it in order to try to increase the anonymization of the file. So you're always gonna be a little bit off. Here we're literally just 1,000 people off. But if you're very close, you know you're doing it right. Okay. So we got the first number. Now the next number is the civilian labor force. So how do we get that? Let's go back to our friend Pimler. Here we go. Okay, so the labor force is defined as these 4 people. That's the labor force. So you either got to be employed or you have to be unemployed, where unemployed means that you are laid off, meaning you're, like let's say you work, this used to happen because I used to live right by a GM plant, and I had neighbors that were GM workers, and they would sometimes just be on layoff because there was not enough demand or whatever, and they would just shut down the production of cars, and they wouldn't be they would be unemployed sort of, but they're just waiting to get called back. So everyone knows that, okay, maybe we're going to be shut down for a month because we don't have any cars to build or something. But then we're going to get called back and we'll work again. So you either got to be on layoff like that, or you got to be looking for work. If you are one of these 3 people and you're not looking for work, then you're not in the labor force. And they actually break this down into 3 little categories here, right? Retired, disabled, or other. But for our purposes here, they're all the same. So we really just want to get the population that either has a 1, 2, 3, or 4 here. So we can go back into here, and that's going to be pretty easy, right? So if Pimler, the other thing is, notice with this bracket one, you have to put spaces right here, right? You notice how there's a space right here? If you don't put the spaces here, it doesn't work. You'll get an error. But here you don't need the spaces. I don't know if you put a space, if that would be a problem or not, but for one reason or another, you don't do the spaces. Okay, so if Pimlar is greater than 0 and Pimlar is less than 5, then, and we're going to create another counter here, labor force equals 0. Whoops, again, no spaces there. And we're going to do the same thing. Labor force plus equal, P doesn't wait, phi to finish it up. And we're going to go ahead and do the same thing here. 1, 2, 3, 4, 1, 2, 3. I don't know why I'm getting that. I think it's because it's in the other. Okay. All right. So Pimlar, if it's greater than 0 or less than 5, well, what's greater than 0 or less than 5? 1, 2, 3, and 4, right? So that should work. Let's see what we get here. As you can see, I mean, it's a little slow, but it's not that slow. I mean, all things considered. All right. You don't do plus plus here. You do plus equals. So that's just a mistake on my end. Plus plus will increment the variable by 1. So it would just add 1. But you don't do plus plus with another variable on the other side. So that's an obvious mistake. But, okay. Oh my. What am I doing? What am I doing here? Oh, it's because labor force already has a value from a prior file I did. And so it actually just inherited that from the bash environment. Is that the right word? Anyways, here we go. This is the number we're looking for, right? I think. Boom. 165.70. I'm off by 1 again. No big deal. So there you go. Now we got the participation rate. So the participation rate, if you've heard this, you're like, what percent of, what's the labor force participation of women, or what's the labor force participation of prime age adults, or whatever. Participation rate is just the civilian labor force divided by the civilian non-institutional population, all right? So we can do that actually quite easy. Participation equals labor force. In this case, I'm going to multiply labor force by 1,000, and this will make it have. It will give us the percentage, but with an implied decimal. Because remember, like normally, if I were using Python, I would just write it like this, and then when we get some number that would say 0. And if we look, it would say 0.621, right? But we don't do floating point with bash. So you got to do something that's an integer and then imply the decimal. So if you multiply it by 100, that'll get you like a 2-digit number. If you multiply it by 1,000, you'll get a 3-digit number with 1 implied decimal place. So we're having fun. Why not? Why not work around the fact that bash cannot do floating point arithmetic? Why not? You don't actually necessarily need floating point arithmetic as long as you're willing to be clever with how you manage these things. All right, that didn't work. What's going on here? I need to put this up here because these actually change the value of those variables. And that's not what I'm wanting. Is that right? Is that the problem? I don't know. Let's give it a shot. No, that's probably not the problem. What's the issue here? It's just a freaking typo. Okay. Bash is not going to tell you. So like in Python or whatever, if you tried to print a variable that wasn't previously declared, it's just going to tell you that variable is not previously declared. There's nothing here, and you're going to get an error. Bash is not going to give you an error because if you don't previously declare the variable, it just sets the variable equal to an empty string. So like all variables, essentially, all variables that you could ever imagine are initially set equal to an empty string. And if you just print that variable, it's just going to print an empty string, even though you've not assigned it anything. It's not going to tell you, hey, you're trying to print an unassigned variable. What's going on? And throw you an error. So, that's fun. That's a fun problem to deal with. All right, so what do we get? We get 620. Remember, there's implied decimal point here. So it's 62.0. And here we get 62.1. We're having fun. All right. And now we can do the same thing for the employed number, right? Employed out, it's just these two. So let's just copy this and modify it a little bit. It's got to be less than 3, right? And then we're going to do employed. Let's add that up here. Whoops. All right. And then we'll do this. All right, what are we looking for employed? We want 158,692. That's the special number. Let's see what we get. 158,691. We're off by 1 again. Good enough. Okay, employment to population ratio. Remember, the participation rate was just the civilian labor force divided by the civilian non-institutional population. That gets you a percentage, right? The employment to population ratio is the same thing. It's just the employment divided by the population, right? So we can just do that here. We can actually, they usually call that EPOP. EPOP. So we'll call that EPOP here. We can echo the EPOP. What are we looking for EPOP? We're looking for 59.7. See what we get here. Big money, big money, big money, big money. 59.6, right? 596 with one implied decimal place. Perfect. Now we want unemployment. Unemployment is just these two, right? So it's just going to be the same thing again. Let's go ahead and try this. Well, unemployed. Now there's a cleaner way to nest all of this, but who cares? Who cares? We want it greater than 2, and we want it less than 5, right? And then we're going to say unemployed. And let's go ahead and skip some steps here. So unemployed, and then we want also the unemployment rate, right? Unemployment rate. So this is a little bit weird, right? So the employment rate, which is also called the EPOP, you divide employed into the population, right? Now you might think, well, the employment rate must just be the opposite of the employment rate, right? So you would just take the unemployed and you divide it in the population. No, some people call that the non-employed rate. But for the unemployment rate, you divide unemployed into the labor force, right? So it's a little bit different. So we'll do that here. We'll call that the unrate, unemployed, and then this actually needs to be labor force. Okay, so let's see what we get. We want to echo. Let's move this up. We want to echo the unemployed and then echo the unrate. All right, let's see what we get. What are we trying to get? We want to get this. This is 6,378,000 unemployed people for an unemployment rate of 3.9%. And what do we get? 6,378. Right on it on that one. And 3, we get 3.8. Remember 3 with the implied decimal point. Close enough. All right, so now we're going to go to the last stat here, which is not in labor force. Guess what we're doing there? We're just adding up these 3, right? So people usually call this NILF, which is a little uncomfortable, but it is the way it is described. That is the norm. Okay, so we want something that's greater than 4. We really just need to say greater than 4 because there's nothing after 7. But, just to, I'll say and less than 8. That way we know it's either 4. We know it's either 5, 6, or 7. And we want to do NILF. Now, you could derive this without doing this because we already know how many people are employed, how many people are unemployed, and we know the civilian non-institutional population. So if you take the civilian non-institutional population, you subtract out the employed, you subtract out the unemployed, then what's left is the NILF. But let's just do it explicitly. In fact, actually, we can do both for fun. Why not have fun just to show you the relationships between all these variables? Okay, so we got that one. That's like the formal NILF. Now we're going to say, we're going to kind of create, I don't know, like NILF, deduced. And so for NILF deduced, we're going to take the population, which is the civilian non-institutional population. We're going to subtract the employed and subtract the unemployed. And NILF deduced, hopefully is the same thing as NILF. We'll see. All right, what are we looking for out of NILF here? 100,892,000 people. So this is how many people who are above the age of 14, who are not in the military, not in prison, not employed, and not unemployed. There we go. 100,891, 100,892. Why do these two differ by one? The answer is almost certainly somewhere, and I'm sure I could think about it if I wanted to really spend time, because of some of the rounding that occurs when you do stuff like this, because Bash is not going to do floating point. Some of the rounding that occurs in this stuff here has made it to where it's one off. But you see, they're the same thing. Not in labor force is just population minus employed minus unemployed. And you could do this with all these variables as well, right? So like employed is just the population minus the unemployed and minus the NILF. And then unemployed is just the population minus the employed and the NILF, right? So the whole population is either employed, the whole civilian non-institutional population is either employed or unemployed or not in labor force. So if you add up these three numbers, employed, unemployed, and not in labor force, you add up these three numbers, you'll get this number here. Yeah? And if you add up these two numbers, employed and unemployed, you'll get this number here. So there you have it. It's as simple as that. Persons who currently want a job, I'm not going to do that here because I've actually found that one's a little bit difficult. There was like I used to do this, but anyways, it's in here somewhere. Here it is. Yeah. If you use this, you can get how many want a job. So fuck, I'll do it. A little extra for you here. So 417 to, okay. So the universe, notice the universe here is Pimler 5 through 7, right? Pimler 5 through 7 are people who are not in the labor force, remember? So we're only counting people who are not in the labor force. If you are not Pimler 5 through 7, you're going to get a -1 here. And if you get a -1 here, that means you're not in the universe. So this is only being asked to people who are not in the labor force. It's an interesting question, right? Because we have this idea of some people are unemployed and some people are not in the labor force, right? And you go, what the hell is the difference? They're both not working, right? That's what they have in common, is that they're both not employed right now. And the distinction is sort of like, well, the person who's unemployed, they're not working, but they're available for work. They're in the labor force. They're like on the sidelines right now. It's sort of like, yeah, you could use a sports analogy here. Imagine a basketball game. You got the 5 guys who are currently on the court, and then you got the other 10 guys. Is it 10 or 5? I don't know. You got the other guys who are sitting on the bench, right? And in a way, you could say, well, the guys on the bench, how are they any different from the guys in the stands? They're just watching the game. They're just spectators, right? And you go, no, they are different because they could come into the game, right? They're ready to go. They could come into the game, okay? So that's kind of a nice little analogy, metaphor, or whatever to get your head around what's the difference between an unemployed person and someone who's NILF, not in labor force. But in practice, they then go and they say, hey, if you are NILF, do you actually want a job? And someone might say yes. So how do you then distinguish? What's the difference between someone who's NILF and wants a job and someone who's unemployed? And the answer is you have to have been doing some search activity for a job in the last 4 weeks. So you have to say, yeah, I've been looking for work. So these are people who are not currently working, not currently looking for work, but when you ask them, they say that they want a job. Now, what you'll find, and this is one of the reasons why I really don't like the unemployment rate, is that the difference between unemployment and not in labor force is kind of it's kind of bullshit, right? I mean, like the idea, it's basically a mental state. It's really almost more than anything else a mental state. Now, I guess they technically define it by job activity, like how much are you looking for work or whatever. I don't even know what that means, right? Like these days I could look for work by just going onto a job board, take like 5 seconds. Now I'm looking for work. It's kind of a silly thing, but like really it's almost like a mental state, right? The difference between someone who's unemployed and someone who's not in labor force. In which case, is a survey really going to be able to suss that out? And what you'll find, actually, not to go off on a tangent, is as the labor market picks up, it's not just that people who were unemployed start taking jobs. It's also people who were not in the labor force start taking jobs. Like every month, millions of people who were not in the labor force, maybe not I think it's, I don't know. It's a lot. A lot of people who were not in the labor force in the prior month, right, told the census taker, they said, nah, I'm not in the labor force. They then took a job. So obviously you were in the labor force in the sense that you were like the player on the bench, right? You were available in the pool of workers, pretty much. Whatever. I don't really, this is one of the reasons why I hate this stuff. I don't want to hate, but like the unemployment rate, all this shit, it's like there's a little bit of false precision here in our understanding of how big the labor force is, who's unemployed, who's not, is a little bit of false precision here. But I didn't want to go down that tangent. Let's see how many people are who are not in the labor force and want a job. Right? Okay. All right. So we're just doing the same stuff here over again. Let's see what we get here. All right, let's remind ourselves what we're trying to do here. So these are people who are not in the labor force. They're among this 100 million, but they say they want a job. And we're looking for 5466 as our final number here. 5465, we're off by 1, just like all of them were off by 1, pretty much. So we're right there. So yeah, there you have it. Let me bring my head up. I think this is right. That's how you do it. That's how all this works. It's all just derived really from that one variable. And then there's a few more if you want to go down. In the current population survey, PIMLR, you use PIMLR, you use the weights, and you can recreate all of this. And then if you want to do more, right, men 16 years and over, it's the same thing. It's just again and again, and you're gonna, but you'll go and you'll isolate sex, right? So here's PE sex. You would isolate number 1, and then they also have age, and right. So the rest of it's just that same thing. You would get men 16 years and over, men 20 years and over, women 16 years and over. And then even with the other tables, well, this is what I have right now. Even with the other tables, it's the same thing over and over again, right? So here they have it by race. Well, you just do the same thing, but you use the race variables to isolate people who are white, people who are black, so on and so forth. The same thing for educational attainment, right? Isolate that. You use the educational variables to do that, right? So what are those? Highest level of school completed. You would use this variable, right, to isolate the people. So you can recreate literally all of these tables here, all of the A tables. You can recreate it using the basic monthly CPS, and you could do it with Bash if you wanted to. It's kind of nuts, but like you can do it, and as you can see, it's not that hard. So, oh shit, I've had my face on, but yeah. Anyways, comment, all this kind of stuff. I meant to show you this actually. Sorry. Hey, it's a sincere kind of thing. Maybe I'll edit the video. Probably not. That's a lot of work. But anyways, you see all these other things with race and sex and education. You can do all of that, right? Just by going into here, and like here's education, and there's a sex variable, and here's the race variable. So it's just the same thing over and over again, but just with different demographic slices. So you can recreate all of this. But yep, that's what I wanted to show you today. More videos coming, of course. Leave your comments. Let me know what you think, and I will see you later.